We've learned how to divide with fractions using reciprocals and flipping over the second number. We're going to take that idea and bring it into today's topic, which is in purple, dividing with whole numbers and mixed numbers. And our I can statement is down here on the bottom. I can convert mixed numbers and whole numbers into fractions before I divide. I'm going to convert. That means change the way they look. So they're going to start as mixed numbers or whole numbers, and they're going to get changed into fractions that mean the same amount as those whole numbers and mixed numbers. So very quickly, here's the whole number 6. To convert that into a fraction, all I have to do is put that 6 on top of 1, because a 1 means my whole isn't getting cut into any parts. I have wholes there. So the way I read this again is 6 wholes. That is not 6 once, that is 6 wholes. And then the other one, the mixed number, here's 2 and 2/3. To convert that, I have to remember to make it MAD, M-A-D. So first is multiply. So I put the time symbol in between the 3 and the 2. And then it's add. And then it is denominator or divide. But we'll call that denominator. I'm going to grab a different color that I haven't used. So the down number. All right. So I'm going to go right around. Oops, I forgot to put in the add symbol. There we go. All right. So we're going to go right around. 3 times 2 is 6 plus 2 is 8. Notice that answer is on the top. And for the down, the denominator stays the same. It was 3 and it still is 3. It's exactly the same. All right. So ideally you've got that mastered. That is a 4th grade standard. If you don't have that mastered, we're going to have to keep on practicing because you'll be doing that all the way through middle school. All right. Here is example number 1. But before we do any dividing, we're going to do a couple of quick steps. So step number 1 is to think about what the problem says. Because when I read divide by sentences, my brain doesn't immediately think, oh, I know exactly what that means. So this problem on the left says 9 1/2 divided by 4, right? But that is tricky to think about. What does divide by mean? So we're going to change this into how many groups of 4 are in 9 1/2. Even that is a little bit tricky, all right? But I can kind of envision groups of 4, all right? And I'm going to try to use groups of 4 to make a total of 9 1/2. So let's make that even a little bit easier, all right? So here is step 2, make an even easier problem to quickly find a reasonable estimate. And the easiest thing to do to make it be an easier problem is to just forget about the fractions. When we do the work, we'll bring the fraction back in. But this now says 9 divided by 4. This is saying how many groups of 4 are in 9. Well, here's a picture of 9 1/2 cookies. But I just said, let's pretend that it's not 9 1/2. So I'm going to eat this part here. Sorry because I didn't share it with you. All right. I'm looking for groups of 4 inside of this. All right. So I can see here are, oops, thought I grabbed a smaller one. Let's try that again. Here is a group of 4. This is my first group of 4. And here is a group of 4. That's my second group of 4. All right. This last thing over here is not a group of 4. So I was able to make 2 groups, but not 3 groups. All right. So I know that 9 split into groups of 4 is going to be more than 2, but less than 3. And my brain is really good at doing these types of problems as soon as I start thinking about cookies, because I can envision cookies and mowing them down, eating them up pretty quickly. All right, here we go. Here are the steps. If you want to divide, so double check, we are dividing. Now I'm going to look on the right side. So that's my number on the right. And it says find the reciprocal. That's the flip it over part. But here's the problem that we're having. 4 isn't a fraction. So I have to make it be a fraction. So before I go any further on, I'm going to rewrite 9 1/2 divided by, but I have to rewrite 4 as a fraction. So that's 4 over 1, 4 wholes. Now I can do that third step of find the reciprocal. Flip that fraction over, find the reciprocal. There it is. So if I flip it over, instead of having the 4 on top, the 1's going to be on top, and the 4 is going to be on the bottom. And the last part of the song says, and then I multiply. So that means I have to change this symbol to a times problem. Make sure that changes there. And notice the 9 1/2 just stays in front. But I'm still not ready, because our I can statement says that we're going to convert whole numbers, which we did. 4 became 4 over 1, 4 once or 4 wholes, right? And we need to convert mixed numbers. So now I need to go back to 9 1/2 and make it mad. So I'm going to put in the times, I'm going to put in the plus, and immediately I'm going to say the denominator doesn't change. Now if I work my way around, 2 times 9 is 18, plus 1 is 19. So that's 19 halves times, and this is 1/4. All right, I'm looking for common factors to try to simplify. I like having a 1 in a diagonal because there's only one way to write 1 as a product, and that's 1 times 1. So I have to write 2 as 1 times 2. And notice when we cross out our common factors, it doesn't change. I still have a 1 on the top and a 2 on the bottom. I still have a 1 and a 2. That's exactly what is in that diagonal. All right, there's only a couple ways to make 4. One of them is to say 2 times 2. 2 times 2 makes 4. But if I use 2 times for 4, then I need to use 2 times for 19. And 19 is an odd number, so 2 isn't going to work. If I skip count by 2, 2, 4, 6, 8, 10, I'm never going to get to 19. So 2 times 2 isn't going to work. So let's try something else, like 4 times 1. This is the only other multiplication sentence where the answer is 4. 2 times 2 and 4 times 1. All right, so 4 times 1 works, so I have to try to use that bigger number, this 4. I want to try to use that first to make my 19. So if I count by 4s, 4, 8, 12, 16, 20, oh, that's not going to work. But notice the other number here, the other factor was 1, so I'll have to use 1. That's 1 times 19. All right, now I'm going to cross out the common factors. 1 and a 1, and it looks to me like I'm left with a 19 and a 4. In this problem, our numbers didn't get smaller. It's still 19 on top, 1 on the top, 19 and 1 are my numerators. That's what we saw up here in the original problem, 19 and 1. And for my denominators, 4 and 2, 4 and 2, that matches. Sometimes that's going to happen, not very often, but sometimes it is. That's because there weren't any common factors other than 1. All right, let's get into this. I'm ready to multiply across. It's still not too tricky. If I multiply across, in the orange I have 19. Be careful, don't add. And in the denominator, 2 times 4. 2 times 4 is 8. All right, so now I need to convert this to a mixed number. I know the denominator is not going to change, so I need to multiply first. Some number of 8s will get me close to 19 without being too many. So if I did 3 here, this now says 8 times 3, and that's 24. That's too big. We are going for 19. All right, so I'm going to grab a 2 instead. 8 times 2 is 16. That's a lot better. So I have 16 plus something equals 19. So if I just add on 17, 18, 19, that 3 goes right here. And remember on the last screen, we said, gee, I'm having trouble with my eraser. We said our final answer should be more than 2 but less than 3. Well, that's what this says. Let me scroll back. Our final answer is more than 2 but less than 3. Take a look. We have a whole number of 2 plus a little bit more. That's 3/8. All right, we're going to do one more, and I'm going to try and go just a little bit quicker on this one. So here's the next problem. It says 8 divided by 10 and 2/3. Right? Here it is, 8 divided by 10 and 2/3. So my first step is to think about what that says. That says how many groups of 10 and 2/3 are in 8. All right, so I'm going to come down and look at my cookies. All right, I have 8 cookies, right? So I'm going to just make a slightly easier problem. Instead of looking for groups of 10 and 2/3, I'm going to say groups of 10. And I get this 10 from going right back up here and just forgetting about pretending that 2/3 isn't there. So take a look at these cookies. Here are 8. Can I put them together or split them apart in any way to get 10 cookies inside a group? I can't do groups of 10 because there's only 8. If I wanted groups of 10, I'd have to add 2 more cookies on the end. Then I would have 1 group of 10. But because those cookies aren't there, my answer is going to be less than 1 group. I'll highlight that. Less than 1 group, right? Less than 1. Last time we said our answer should be between 2 and 3. This time it should be less than 1. So here we go. If you want to divide, division symbol, look on the right side. So here it is on the right. Find the reciprocal. But we're going to have that same problem that we did in the last one. 10 and 2/3 is not a fraction. It's a mixed number. So before I can find the reciprocal, I need to rewrite this problem. 8 divided by or split into, instead of 10 and 2/3, I'm going to make it mad. So I'm going to multiply, add, the denominator stays the same, so that's thirds. This isn't too tricky. 3 times 10 is 30, plus 2 is 32. So 32 is on the top. All right, so that step again where we're at is this third one, find the reciprocal. So now I need to put in those arrows and flip it over. So 3 isn't on top anymore. Sorry, 3 isn't on the bottom, it's on top. It's the numerator. 32 is the denominator. Find that reciprocal, and then I multiply. Put in the times symbol and multiply. So that 8 in front, it has to be a fraction. So immediately I can rewrite it as itself on top of 1. All right, here we go. I'm always looking at the diagonal that's got a 1 in it because I know it's not going to change, but I can rewrite it as a product. So 1 is the same as 1 times 1. So that means 3 needs to be 1 times 3 so I can have something to cross out. So my common factors are 1 and 1, and notice it hasn't changed. It's still a 3 as a numerator and a 1 as a denominator. When you have 1 in a diagonal, it's not going to change. All right, let's look at the other diagonal. 32 has a ton of different ways to write it as a product, as a times problem. And 8 has a few of them too. Kids are really tempted to do this first. 2 times 4, and then 2 times 16. But I want you to notice that if you just do the 2s, if you do that, you're left with 4 and 16, and you can make those smaller still because those are both even numbers. So again, I'm going to challenge you to not just use 2. The greatest factor of 8 is 8. Get rid of 2 times 16. The biggest or greatest factor of 8 is 8, so 8 times 1. Because I want to try to use 8 instead of 2, because that'll leave me with smaller numbers left to multiply. All right, so if I count by 8, I think I'll get to 32. 8, 16, 24, 32. I will. So that's the fourth number here. So that means that's 8 times 4. Cross out my 8/8 because that's a whole. Oh man, this is pretty easy now. Oh, look at this. There's even a 1 and a 1, so there's a 1 whole hiding in there again. So I'm going to cross those out. I love it when that happens. 1 whole. And now, here's my answer just hiding there. The answer is 3/4. And let's go back to our cookie problem. We said that our answer should be less than 1. And our answer is less than 1. We had less than 1 group of 10 cookies. We couldn't even make one group of cookies, one group of 10 cookies. That's why our answer is less than 1, and 3/4 is less than 1. I think of these as puzzle problems, and they get to be more fun as you practice.